point in 3 dimensions
Yeah, X,
and
Y,
X
Z.
squared and like
X,
that.
Y, Z,
Okay.
yeah.
So I want to understand this sum of squares, and I just want to arrange this sum of squares as the number of points that I'm going to list. So for instance, 1 squared has to do with the point 1, 1, 1. And 2 squared has to do with the points 2, 1, 1, 2, 1, 2, 2, 2, 1, 2, 2, 2. So the first number just means which one of these terms in the sum do I have, and these are the points in a square that's size 2, and it's supposed to be this picture. And so I keep going like that. I don't want to write all of these. And now the question is, what's special about the points I've written down? And what's special about the points I've written down is that the first number in this triple is always at least as big as the other 2. Do you guys see that? Now there is a set of points that I really understand very well, which is the set of all the points where I have integers as the coordinates, but each one of them is between 1 and 100. That's a cube. And there are 100 cubed points like that, which is 1,000,000, right? And I want to know kind of what share of those points have I listed here. And what I know about any one of those points that have 3 coordinates that are between 1 and 100 is that there's a largest coordinate. There might be a tie. It might be that 2 values of the coordinates are the same, but one of the coordinates at least is largest. And if it's the first one, it's in this set. And if it's the second one, it's in a set that's exactly the same size that I could have chosen by making the second coordinate like that. And then there are the ones which have the third one being the largest. So this is close to 1/3 of those points, except that there's some double counting going on. Do you understand what I mean? I could take this cone and I could make 3 copies of it that are oriented differently, and those 3 copies kind of fill up the cube, except that they have some sides in common.
So do you see which ones are double counted? You do that with the 1 to 100 adding also, right? There's one special.
Well, you just kind of don't notice it.
Yeah, you don't notice it, but in that case also there's one special too, right?
They all start with the number that's being squared.
Right.
Okay, so let's try to do this in algebra. We don't know what this number is, so we should give it a letter. And 3 times this letter is really close to 1,000,000, but it's not quite 1,000,000. Because what happens is that when I write 3 times this, so it should really be minus. When I write 3 times this, there are some points that are double counted, which are the points that have 2 largest coordinates the same. So maybe I have the point 2, 2, 1, and 2, 2, 2. And it's in two of these points are in two of these sets. The set where the second coordinate is largest and the first coordinate is largest. And I could say 1, 1, 1 is also in two of these sets. And